Right. So Intel has been in the field of AI since the early days of machine learnings, deep learnings, etc., even before the surge of generative AI and agentic AI. And what we believe is that the silicon as a foundation of the compute should be equipped with the tools that helps us run these AI workloads. That's why Intel has invested hugely in features such as AMX, which is advanced matrix extensions that help you speed up the AI workloads up to 2 times the speed. Also, for the sovereignty side of things, there is something that Intel invested heavily on, which is the topics of confidential computing that covers some of the aspects of sovereignty. And these are some solutions that are namely called TDX and SGX that allow you to separate your virtual machine or your application depending on the granularity that you want to reach to. And then last but not least, we also have some tools that we also embedded in the hardware themselves that allow you to actually take advantage of the memory that you are using by compressing the memory so that you have more headroom to process more workloads with the same hardware that you have available. When we speak about co-engineering, that's basically where we collaborate with a set of partners, with community members, with developers, so that we can come up with a solution that would work for the real world use cases, right? And co-engineering is very important because it's about leveraging all the resources that each organization have, but then gathering them and bringing them together, which gives you that exponential way to reach to your goal, as opposed to each company working on their solutions separately. So that's how we see co-engineering as a key tool. And in fact, many of the projects that Intel is leading are being co-engineered simply because they are open source, so Intel is participating, but also other organizations, other independent developers are also participating. And I think that's one of the best way to kind of create knowledge that we know it will be matching the needs of what our customers are expecting. Xeon 6 is in the family of our Xeon servers. So before that, we had several generations of Xeon servers. Starting from Xeon 4, we had introduced a feature that is called AMX, Advanced Matrix Extension, that allows you, as I said, to speed up your mathematical calculations up to 2-fold, right? So in Xeon 6, it's a mature feature because we've been releasing it with Xeon 4, Xeon 5, and now it's Xeon 6, right? So this capability, what it gives you, in a sense, is it gives you the possibility to run large language models that are up to 20 billion parameters on your Xeon 6 server that is probably sitting there while, for example, when the customer may be thinking that to run AI, they need to grab the most expensive GPU or another rack of GPUs so that they can run AI. So basically, it makes running AI such an easy pathway because it builds on something that most enterprises have in their baggage, which is a Xeon. They use it for other applications, orchestration, databases, etc. But it can be used also for AI.